In this video we're going to have a look at the interactions between force, mass and weight of an object. And to begin with, we're going to look at a thought experiment that was first done by Galileo Galilei back at the end of the 16th century in Italy. Now at the time, most people were thinking how Aristotle and the Greeks thought, and that heavier objects would fall faster than smaller objects. So what we're going to do is we're just going to run through Galileo's thought experiment and show why this can't be true. So Galileo asked himself, if heavy objects, such as our big red objects over here, fall faster than green objects, then what would happen if we put them into a bag together? So let's say, for instance, that our red object does indeed fall faster than our green object. When we put them in a bag and we drop them down together, then what should happen is that the lighter green object should pull the bag up a bit as they're falling, so the red and the green object together wouldn't fall as fast as the red object on its own. However, if we put these two together in a bag, then the combined weight of these two together should mean that the bag itself is heavier, so the bag should fall faster than the red object on its own. And this, as you can see, leads to a contradiction, and therefore the initial hypothesis that heavy objects fall faster than light objects can't be true. So from this, Galileo concluded that all objects fall at the same rate. Or to be more precise, all objects accelerate under gravity at the same rate. And here on Earth, or close to the Earth's surface, that is approximately 9.81 meters per second squared. Now Galileo did some other experiments where he would roll a ball down an inclined plane. And what we can see here is that the ball will roll down the plane, come to the bottom, and then roll along. And if there was no friction involved on the surface, it would then start to come back up the other side of our bowl, and like I said, without any friction, then the ball will come back up to the same height that it was dropped at. And then what he thought was, what would happen if the slope of this ramp wasn't as inclined as it was previously? So let's draw that in something like that. And again, what he realised was then, as the ball was coming up this ramp, it would still, because there's no friction involved, still manage to make it up to the height that it was dropped from. And in order to reach the same height, what we can see is that the ball has had to roll further along the inclined plane in order to get back to the same height. And now for the final part of the experiment, or the thought experiment, what Galileo now did, I can get my rubber out, was he then thought, well, if we make the inclined plane not actually inclined, and so it would just go on a straight line, then the ball, as it rolls down, it would come along, and it would want to come back up to the same height, but because there's no plane to roll up, it would just keep going. And this is the property of the ball that we would call inertia. And inertia is the property of the ball, of any object, to resist having a change to its motion. So in this situation, it would move with a constant velocity forever. So in conclusion, as we've just seen, by studying the motion of falling objects, Galileo was able to come up with a new principle one that he called the principle of inertia, and that says that an object, not subject to any external forces, moves at a constant velocity, i.e. it has a uniform motion.